Hi, today I want to talk about directional derivative and gradient. So basically, gradient is something like, for example, the gradient of a function f of x and y. It just tells us how does this value change in terms if x and y change, and then in a specific direction. And derivative of so something like df dx, df dx and df dy is basically calculate the change of f of xy in the direction of x and in the direction of y. However, let's say if we want to know how does this value change in terms of other directions, then we need to calculate directional derivative. So for example, let's calculate. So we are asked to calculate the directional derivative for this function in the direction of from 1, 4 moving to 4, 8. So first of all, let's calculate the vectors that is pointing to that direction, PQ. So a vector that is parallel or it is on pointing in that direction, PQ, is basically the difference between these two vector. So it's 4. So the x is equal to 4 minus 1 and 8, and the y is equal to 8 minus 4. So the direction is pointing so the vector is 3, 4. So since we are moving from 1, 4 to 4, 8, so it's pointing it's moving so it's like if you can say it is increasing or moving to in the positive direction. So that's why these terms are always positive. So if you are moving from this to this direction to this, then you should use 1 and 4 minus 4 and 8. So since like the term is all positive, so that means it is moving in the direction that both values are increasing. So moving from P to Q is basically using the ending points minus the starting points. And so that is the direction vector, and now we also need to we need to calculate the unit vector in that direction. So basically it's use the vector divided by the magnitude. So the magnitude for this is 3 square plus 4 square and then take the square root. So basically is 9 plus 16, 25, and then take the square root is just 5. So the magnitude of this vector is 5. So that the unit vector will be 3 divided by 5 and then 4 divided by 5. So this will give us the unit vector that is parallel or pointing to that to the direction that is pointing from P to Q. So now let's calculate the gradient of our function f of x and y. So basically just taking df dx and then also df dy. So this is just I'll just give you the solution. So this is the gradient of our function f of x and y. To calculate the directional derivative, basically is just use the gradient multiplied by the unit vector of the direction that we are looking for. So basically it just and we also need to plug in 1 and 4th, since we are calculate the direction. So this moving from P to Q just give us a direction, but we are still trying to figure out the gradient at the point P. So we plug in the value, the coordinate for P, while multiplying the unit vector that is pointing from P to Q. So we plug in 1 and 4 into this gradient, and we multiply by the unit vector of P and Q. So this will give us the directional derivative. So basically that so if we are moving 1 unit from P to Q, so P and Q give us a direction. So if we are moving 1 unit in this direction, we are going to have a change of this f of x and y by negative 19 over 40. So this will give us the unit, the change if we are moving 1 unit in that direction. So this is how you calculate the directional derivative. So basically, it's just calculating the change of f for any direction that is other than x and y. Otherwise, this will just give you the change or the derivative that is pointing in x and y. But if you want other direction, then you need to multiply your gradient by a unit vector that is parallel or parallel to the direction that you are looking for. So this is how you calculate the directional derivative. And also, let's say, and also with gradient, we can also calculate the let's say the tangent function at a point. So let's say we have a question like to use the gradient to find the equation of the tangent plane to the surface of this. So let's say, so for this surface, which is actually a level surface of this function here. So this function is actually a 4-dimensional. But if we set this function equal to 9, and then we will get a level surface of this 4-dimensional function here. And then while taking the derivative of this function with three variables, with respect to x, y, and z, we will get the gradient of this function here. And at the point P, we basically just plug in 1, 2, and -1 into this gradient. And then we'll get the gradient of this function at P. It's just 0, 13, and -39. And then since we are going to calculate the tangent plane to this surface, we since the gradient is already normal to the level surface, so the equation for a tangent plane is just the normal vector multiplied by the difference from multiplied by x minus x0, y minus y0, z minus z0, where the x, y, z at is 0 is just at the point that we are looking at. So basically, it's just the derivative multiplied by x minus 1, and then the gradient multiplied by y minus 2, and then the gradient multiplied by z plus 1. So this is the tangent plane to the surface at the point of this. So gradient is a normal vector that is it's a vector that is normal to the surface at the point P. And to get the equation of that plane, basically it's just the gradient multiplied by this, which is x minus x0, y minus. So it's just that we need to subtract from this from the point that we are looking for. So this is how we calculate a directional derivative, and to use the gradient to find the equation of the tangent plane. So thank you very much for watching.